What if the hardest part of building intelligence was not the math, not the code, not even the data, but the way you think? What if most teams fail not because they lack talent, but because they walk in the wrong direction with great speed? You sit in front of a screen, the model trains. The accuracy moves, up, down, you feel busy, you feel productive. Yet something feels off, progress feels random. This is where this story begins. Machine Learning Yearning is not a textbook. It does not try to impress you. It tries to save you time. It speaks to you like a calm mentor who has already made the mistakes you are about to make. Andrew and Guy wrote it for builders, not theorists. For people who want systems that work in the real world. For people who want clarity in chaos, you start with a dream. A system that sees, a system that understands, a system that helps millions. You gather data. You build a model, you test it, it fails. Not completely. Just enough to hurt. Now comes the temptation. Change the model. Add layers. Tune hyperparameters. Try something new. Anything new. You hope progress will appear. Andrew NG stops you right here. He asks a quiet question. Do you know why your system fails? Most teams do not. They chase improvements without diagnosis. They treat symptoms. They do not identify causes. This book insists on one discipline above all. Understand the error. Error is not a number. Error is a message. Every mistake your system makes tells you a story. The problem is that most people never listen closely enough. They see an accuracy score and move on. Andrew tells you to slow down. Take a sample of errors. Look at them one by one. Classify them. Name them. Count them. You discover something uncomfortable. Many errors come from a single source. Bad labels. Rare edge cases. Low-quality inputs. Suddenly the path forward becomes clear. Not easy. Clear. This is the first shift in thinking. You stop guessing. You start deciding. The book keeps pulling you back to one idea. Focus. Machine learning progress does not come from doing more things. It comes from doing the right thing next. To do that, you need a target. Andrew introduces a single number evaluation metric. One number. Not 5. Not a dashboard. One number that tells you if you are moving forward or backward. Without it, debates never end. Opinions dominate. Progress slows. When teams lack a single metric, meetings turn into arguments. One person wants higher precision. Another wants higher recall. Someone cares about latency. Someone else cares about memory. Everyone is right. Nothing moves. With one metric, decisions become fast. You try an idea. The number goes up or down. You keep or discard. Emotion leaves the room. Learning speeds up. But metrics can lie. Andrew warns you about this too. You must choose a metric that reflects what you actually care about, not what is easy to measure. If your system looks good on paper but fails users, your metric betrayed you. Or more accurately, you chose it poorly. Then comes a subtle idea that changes how you think about problems. Orthogonalization. You break complex goals into independent pieces. Each lever controls one thing. One knob changes accuracy. Another changes speed. Another changes robustness. You do not mix them. This matters because confusion kills progress. If one change affects everything, you never know what worked. You feel busy. You feel smart. You do not feel confident. Andrew wants you confident. He wants each experiment to answer a clear question. Did this improve bias? Did this reduce variance? Did this fix a data issue? Bias and variance appear next. Old ideas. New clarity. Bias means your model cannot even fit the training data well. Variance means it fits the training data but fails on new data. Many people memorize these definitions. Few act on them correctly. The book teaches you to diagnose before you treat. High bias calls for a more powerful model. High variance calls for more data or regularization. Mixing these responses wastes weeks, sometimes months. You feel the tone of the book here. It does not sound excited, it sounds precise. Like someone who respects your time. Then Andrew introduces dev sets and test sets. Not as formal concepts, as tools for thinking. Your dev set guides your decisions. Your test set judges your final result. You do not peek at the judge while practicing. If you do, the verdict becomes meaningless. He pushes this further. Your dev set must reflect reality. If your users live in noisy environments, your dev set must include noise. If your system will face rare cases, your dev set must include them. Otherwise, you optimize for the wrong world. This idea hurts. It means more work upfront. It also means fewer surprises later. The story deepens when Andrew talks about data. Everyone says data is everything. The book says data strategy is everything. More data is not always the answer. The right data often is. You learn to ask better questions. Are errors coming from mislabeled examples, from rare classes, from low-resolution inputs? Each answer suggests a different fix. You stop collecting data blindly. You collect with intent. One of the most practical ideas arrives quietly. Ceiling analysis. You break your system into stages. You measure the maximum possible gain at each stage. You see where improvement matters and where it does not. This prevents wasted effort. Imagine improving a component that can only raise overall accuracy by 1%. Now imagine ignoring a component that could raise it by 20%. Without analysis, teams choose poorly. With analysis, the path reveals itself. The book keeps returning to speed, not rushing, speed of learning. Short feedback loops, small experiments, clear conclusions. Andrew believes that the team that learns faster wins. Not the team with the fanciest model. This idea feels almost boring. It is also deeply powerful. You begin to see machine learning not as magic, but as engineering. Decisions, trade-offs, iteration, discipline. Then the book addresses transfer learning, a gift from past work. Use what others have learned. Do not start from zero if you do not have to. Pre-trained models save time and data. They also change your strategy. When you use transfer learning, the question becomes different. How much data do you need to fine-tune? Which layers do you adapt? How close is your task to the original one? These decisions shape results more than model choice. Andrew never tells you there is one right answer. He teaches you how to find your answer. The narrative continues into multitask learning, one model, multiple outputs. Shared representation. This can help when tasks are related and data is limited. It can hurt when tasks conflict. Again, diagnosis matters. Then comes a hard truth. Sometimes the problem is not machine learning at all. Sometimes it is product design. Sometimes users do not want what you built. Sometimes the data reflects bias in the world. Sometimes automation is the wrong solution. The book does not romanticize intelligence. It respects reality. As you move deeper, you notice something. The book rarely talks about algorithms. It talks about thinking. Andrew assumes tools will change. He builds principles that last. He warns against premature optimization. He warns against chasing state-of-the-art results without understanding constraints. He reminds you that a working system with clear value beats a perfect model that never ships. The emotional peak arrives when you realize what this book really gives you: calm, confidence, a sense of control. You no longer feel lost when a model fails. Failure becomes information. You stop asking vague questions, you ask precise ones. You stop running endless experiments, you run meaningful ones. This is the transformation. You move from hope-driven development to evidence-driven development. The final chapters reinforce responsibility. Your system affects people. Errors matter. Bias matters. Edge cases matter. A small error rate can hide large harm. You must look beyond averages. Andrew does not preach. He points. He trusts you to act. The story closes not with celebration, but with resolve. Building intelligent systems is hard. It requires patience. It requires humility. It requires care. You are not chasing intelligence. You are cultivating judgment. You now see machine learning as a process of asking better questions over time. Each iteration sharpens your understanding. Each failure teaches you where to look next. This is the yearning in the title. Not desire for models, desire for clarity. Desire to build things that work. So here's your invitation. The next time your model disappoints you, do not panic. Do not add complexity. Pause. Inspect the errors. Choose one metric. Decide the next step with intent. Move forward with confidence. If this way of thinking resonates with you, do not just listen and move on. Apply it today. Take one project, one model, one dataset, and redesign your process with discipline. Let your work speak through results. And when progress feels slow, remember this. Speed comes from clarity.